Welcome. This just to recap for as we've usually done. This year, we took the approach of preparing for the PCNSE and through these sessions, so we could open up the doors, allow anyone who wanted to come and join us for those discussions, and we're going to record them. So even if someone's along this journey at a different point in time, weeks or months later, they can tap into this to sort of get a sense for what we've discussed internally, some new things. And I've told our internal team, every one we've done, I've learned something from it. So I'm sure you guys will too. I popped a couple links in before as into the chat because Caitlin is usually here helping us out and is unfortunately away sick today. So just from our team, you guys see those, I think, when you come in, right? I popped in a couple links in the chat. One isn't about us. You guys can go browse through some bios for the amazing colleagues that I have that are on the call today on the Advantus360 About Us page. And the main PCNSE page, which I think everyone knows, but I put that link in. We've commonly referred to the blueprint and study guide, which are located amongst many other things on that landing page. And we may refer them to them today. We're also going to, I believe the team is going to leverage some demo devices because this exam domain is a lot of like how to configure. So sometimes seeing is better than imagining in those cases. And we do have access as a Palo Alto partner to some demo systems, which I think unfortunately will just not be available to everyone. But of course, referring back to our very first session, there's other ways to get your hands on the Palo Alto firewall, next generation firewall, including marketplace and public cloud and other measures there. So that being said, I am going to hand it over to you, Paul, to talk about the first aspect of domain 3, which is App ID, I think.
Awesome. Thank you, Steph.
Yeah.
Hello, everyone. Feel free to interrupt me as I go through some of this. I took some notes for myself. Hopefully it should get through everything, but yeah, feel free to interrupt and jump in or put questions in the chat. So App ID. I want to start with like, what is App ID? Basically, it's a signature behavior-based identification of application from traffic. So it looks at traffic patterns and it identifies what the application that is on that traffic is. So I like to think it's kind of like regex on packets with a bit more definitions of things, different characteristics it uses as part of that. But really, it's a signature-based identification. So SSL applications sometimes are identified without decrypt, often by using a public certificate. This is one that people constantly ask. How does it know it's Google or Facebook? It looks at the public certificate, and if it's a start.facebook or start.google and it's a common public cert, it can identify Google and Facebook based on that without being decrypted. Otherwise, it would typically come up just as SSL because that traffic would be decrypted, and you wouldn't be able to see within that payload. So it'll just say SSL. We'll talk later. Obviously, it's one of the reasons why you should do decrypt. So the next thing I want to show people was the Application Research Center. This is called the Appipedia. It's a great way just to have an idea of what apps exist in the Palo Alto database. You don't, I don't think you need to even authenticate to get to this page. I might already be authenticated. So this appipedia.paloaltoworks.com is a great resource. It has all the characteristics and subcategories, technologies, and things you can build filters on. So if you don't have access to a box or you just want to see what the latest versions are, if they have something that you're working with, check this out. It's a great resource. You can Facebook and search, and you can get all kinds of different things there. Something to pause and take note here is that sometimes there's sub apps to apps. So there's an app like Facebook or a master app, and then there's sub apps like functions within it. Often those functions within it won't be available unless you are doing SSL decrypt or you have the ability to see within the payload. But you can see here, for example, Facebook is like a global one that typically works without SSL decrypt because it's identified again by the SSL cert. But things like Facebook uploading, it does need to know sort of the traffic within to get that further depth. Awesome. I want to move on to application default. So what is application default? Actually, maybe I should stop and we'll talk about security policies first, because this whole section has kind of, it talks about deploying or configuring security policies. So I'm going to jump over to the US1 demo box here from Palo Alto. Thanks, Paolo. Sorry, guys, let me just close that. So security policies is what I'm looking at here. Policy, security, and then it's a top-down match condition, essentially. So from source to destination, service / port, and then app ID. So what are these things? So from is kind of like your zone. This is your source zone. I'm gesturing on the screen, you guys can't see, but I guess you can see it. You just can't see what I'm gesturing at. So there's source zone, which is basically like interfaces grouped together, right? So when you think source zone, think kind of like source interface. There's the zone construct, there's a little bit more than that, but that's what I like to think of. So it's kind of like a source interface or a grouping of those. Address is your source address, pretty typical. There's user device, which we'll get into user ID or device that it comes on. This is like IoT device, basically. Or device that's been identified that traffic's coming from. Destination zone, which I typically call 2, and address, which is destination address itself. So those everyone's probably pretty familiar with. Application is the one that's kind of, next generation. And that's where you have your identification. You can see here they've got things like ping, SSL, flash, things like that. Service is basically your port. This is your service port, right? So think SSH operates on port 22. This is your port 22. Application default, you'll see quite often in relation to an application. So what is that? Basically, it's the application's normal or standard ports. You can see that under any application if you look for one. So for example, SSH is going to be, port 22. Standard ports is TCP port 22. So if you say application default, it is basically automatically replacing that with 22 for you. So if traffic shows up on port 22, it's going to hit that rule. And then it's going to try to identify SSH on it. And I'd say that in a specific order because it does allow that first handshake to cross. And then it identifies the traffic based on traffic patterns. So you will see TCP SYN sometimes go through policy if a port is allowed before an application can be identified, right? And that's obviously just because you can't really identify the traffic until you have traffic. So how often does it take to actually identify it? I'm gonna get a little bit into the weeds here, but basically 4 packets pass the 3-way handshake, so 7 packets total, or 4 packets in UDP. At that point, it makes a determination. If it knows the application based on those first couple packets, it will determine the application, and you may see something called application shifting at that point, which I'll talk about here in a second. There's another limit called 2,000 bytes, basically. So it's 4 packets or 2,000 bytes. And I'll drop a link in the chat here when I'm, you know what, actually, let me just drop this in the chat now because I'm not going to remember.
Well, you are, Paul. Maybe I know when I was going through, I was sort of highlighting things that sort of stuck out in my mind. And I remember learning about App ID and then later having the aha that, oh, wait, this firewall's still a port-based firewall first. And then very, very quickly is a next generation application firewall. And I did not know that at the start. I thought it was sort of just, it did something different to just sort of allow everything on application. But when you really need to troubleshoot or manage the policy, you do first need to allow port-based traffic to then classify and qualify the application traffic to be allowed after. So I'm glad you're digging in on that because I know that.
Yeah, it's a common one, right? Because people,
aha.
Yeah, many of our clients get confused with this. Like this is the details of how App ID actually operates in the firewall, right? So it goes to the whole policy base looking for that port that allows it on a TCP because it won't do even a SYN act, like it won't finish the handshake to the server unless there's a port that allows it. Once there's a port that allows it, that rule will start letting traffic through up to that limit, 2,000 bytes or 4 packets on TCP, or sorry, 4 packets after handshake on TCP, so 7 packets, or 4 packets on UDP.
And that's the service column, Paul, just to look at the screen.
Yeah, so we're hitting that service column first. If it allows it, it's letting those packets through until it gets that ID. And at that point, it can even make its, a decision. If it's yes, it is allowed by this session, it will land in that session. And that's when you go from something called slow path to fast path, right? And you have an established session now, you're allowing it, you don't go back to the policy to check. Or you continue your security profiles after that too. So yes, you go through your policy base with the source, with the port first, basically, all the static elements that don't need constant checking. And then once you've allowed some of that traffic and it can identify that traffic based on App ID, it may settle into a different, and that's called application shifting. So I want to talk about application shifting really quick because this kind of like helped nail it for me. So changing App IDs means that a single flow could move through several rules. So a common example is later in your policy base, you may have SSL. And then earlier than that, you may have something like Facebook. Facebook may actually show up as SSL first because it might see SSL before the certificate. It would see, for example, go through a handshake, you get a TCP session, it's on 443, it makes some assumptions, it thinks it's SSL. You may actually have traffic be permitted through one of your rules, and then once app ID kicks in, it says, oh, actually, that's now Facebook, not just any SSL traffic. It may reevaluate to a different rule. So you may go from one rule to another rule. One of the reasons we typically see log on session end is because of this. If you log on session start, you'll get all these different rules showing up, or you'll get the rule that it doesn't actually settle into, rather than the rule that it ends up passing most of the traffic in. So what happens after? So now you understand, there's the port base, right? And that application shifting that can occur before that sort of settles out. Well, what happens if it hits those 4 bytes, or if it hits that 7 byte limit, or 2000 packet, or 2000 byte limit, I should say, 7 packets, 2000 byte limit? What happens after that? It either becomes unknown TCP, unknown UDP, if it really doesn't know. And that's left to how you guys deal with it. Typically, it's dropped off the policy base. So there's other special applications, our app IDs I want to talk about really quick, and then I'm going to go to configure a little bit. So incomplete data, or incomplete, which basically happens after a handshake was executed, but no data came through before the timeout between those sessions. So it saw a handshake, full handshake, but it did not see data. It's considered incomplete data. You'll see that sometimes show up on your logs. Insufficient data means there was a handshake and there was data, but there wasn't enough data to make a identification, right? Maybe it needed a few more. It was going down that tree, and it almost had enough to properly identify it, but there's no more information. That's called insufficient data. And then non-SYN TCP is when it sees an app without a SYN. Obviously, it's typically dropped by other policies, or non-SYN TCP is typically dropped. But potentially asymmetric routing, things like that. And you may need to look at configurations outside of policy, outside of security policy, to allow non-SYN TCP. You can allow it though, but you might have to look at configurations outside that. Unknown TCP and unknown UDP, as I talked about before, is when you get to that limit, 7 packets or 4 on UDP, or 2000 bytes, and you don't have identification yet. It ends up just going, okay, I'm done looking at my regex statements, basically. I'm done looking through that giant tree of applications I have. It's unknown, and deal with it if you want. You still have the port, you still have those things. Okay, so I want to talk about one other thing first. Application override. So application override is a way to basically take a port and identify it directly to an application. Major caveat here is it skips all layer 7 scanning. It actually changes the way it processes, and it basically just sees a port show up and goes, oh, I have a rule that says that when I see this port, it's this app. And when it does that, it doesn't do any scanning, doesn't do any content ID, vulnerability, antivirus, any of that stuff. So be cautious when you use it. Sometimes people will use it to get an app ID identified, and it's, in my opinion, a poor choice to use because it does skip all your layer 7 scanning. A better way to do it is actually create a custom app ID. Now, when you create a custom app ID, you have to write signatures, or you can create an application override that applies to it. Again, application override will remove that layer 7 scanning. So with all that said, do some, sorry, any questions, Steph or anyone, before I just kind of show rules a little bit here?
The only thing too, Paul, that I was refreshing myself, I think when someone's maybe looking at the exam content, like the study guide, yeah, that bypass of scanning is a big deal. And I think they refer to that as like content ID is the terminology. Right?
Content ID is the scanning.
Content ID. Yeah.
And if it asks on the question, content ID is all those scanning functions like vulnerability, antivirus, DLP, all those things. Right. And the day in life of the package shows that the best, in my opinion.
Oh yeah. So right. Yep.
I'm just going to put some garbage in here. So any source zone, 10.01. Obviously, if you were building a rule in your own environment, you would be using app or address object, not just putting IPs in, but you can just put IPs in if you want. And we're going to say we're going to go to 1.1.1.1. Okay, finally, the application column is the one I want to show you here. So here's what it looks like to put an application ID rule in. I took a note for myself, the ones I actually wanted to show, because I'll show you what I mean. So SSH, common one. I click this one, nothing shows up here on the right. It's all on its own. This will then, I can go to application and I can say application default, which is standard here. And that means it's going to basically allow SSH on port 22. If you want to allow SSH on something that's not port 22, you need to actually put a service in here and build a different port. For example, 2120 255. This will only allow SSH on that. You can't do both. You can't say application default and these ports. So if you want to use application default, you can't use that port there too. Okay, other applications, you'll see a difference here. Let me put in Google Chat. So Google Chat is obviously an application that's kind of under Google, but it's kind of a sub app. You can create rules based on sub apps alone. And you can see here on the right, it'll say depends on. The workflow here is to basically click these and say add to current rule so that you have them there. If you don't have them there, you have to go back to that application shifting. Maybe Google Base and Google Chat is allowed through a different rule and then gets allowed through Google Chat, right? So Google Base and Gmail Base can be allowed through a different rule. And then you could have Google Chat in a different rule and you can actually have the flow bounce between two rules if you want. That's why it's not always mandatory to put it over. You might be allowing it through a different rule, but normally in typical deployment, you're going to put them all in the same rule. So that's, for example, Google Chat. I'm going to delete these and show you one more that's a little bit more fun. Facebook. So Facebook, you can see here has sub apps and it has the master app. I'm going to click the sort of main app here, and you'll see on the right, there's just a bunch of stuff, right? And this just goes back to it's going to use all these different things. It has WebSocket stuff for chat. It has Stun and RTP base. It does RTCP for video context and stuff because Facebook has lots of video stuff. Obviously, you guys probably know that. So again, depends on add to current rule. There's a lot of stuff here to allow. You can also see here that it allows SSL. Now, if you have a rule that says SSL, application default, that rule is now allowing traffic to all the internet, not just Facebook. It includes SSL at this point. So consideration for how you sort of build those policies out is important.
So
awesome.
Paul, that dependency is quite important then, I'm assuming. Without the dependent protocol, I'm assuming the rule will be denied, even though if you have, for example, Facebook chat and you don't have the dependencies there, your rule will not work.
Yeah, it's a good way to say just it won't work. In the details, it's like maybe functions of the application won't work, right? So like Facebook depends on RTCP, but it's probably not going to affect you until you're doing some sort of video or media transfer. WebSocket is probably only used for their chat function. So you may have a partially working app, depending on how that app is working out. But yeah, in essence, if you don't have the depends on stuff in there, it probably won't work, right? Something like Google Chat's a little bit more straightforward in that regard, because Google Chat will not work at all, because Google Base won't even be allowed, so it can't get to Google Chat. Chat. So devil's in the details, but yes, if you don't include these things, Google Chat won't work at all in this case, whereas part of Facebook, I think, would work. So.
Yeah, no, that makes sense. Great. And the depend on application does not have to be in the same rule. It could be in a different rule as well, as long as that firewall tree allows that dependent application.
Yeah, exactly. Back to application shifting, you could hit a different rule like SSL, for example. The Facebook one, if you notice, it depends on SSL. So it has to be SSL first before it could allow Facebook. If you have SSL on a different rule, it might hit a different rule, pop back up to the Facebook rule. It's really good if you're trying to do some sort of like specific blocking and things. So you want to see Facebook in a different log. You may not put SSL in that rule. You may put SSL in a different rule that allows the first set of the communication to start SSL, and then it's going to shift once it notices that it's Facebook, not SSL, based on that certificate.
And the shift, Paul, happens top down. So if Rule 5 was, say, an app ID rule, but it depends on was in Rule 3, it doesn't shift only down from where it is, right? It's still if there's an app shift happening, it's still top to bottom processing.
I've seen it go up.
Yeah.
And so I don't want to, don't quote me on that. I've seen it basically reassess the whole rule base.
The whole policy. Yeah.
Correct. Yeah.
Perfect. I'm glad we're all in agreement. Yeah, because
that's what I thought
it
too,
goes up. Like in one of the best example I can think of, SSL was at the very bottom, and then the specific rules were at the top, and it was on purpose. If you don't do that, then you end up hitting SSL, and you kind of like sit in this top one where they actually wanted it to go down, hit SSL, start, and then bounce up to Facebook or bounce up to Twitter or bounce up to Google. So it actually reassesses the entire policy again on that application shift.
So if it's coming from SSL, it's the app ID logic says this is SSL. when it says this is something else, it just retests the policy base looking for that app ID match, basically, wherever else it is. Maybe same rule, maybe not, maybe above, maybe below.
Yeah. Awesome. And
Perfect.
yeah, it's very efficient though. It's not really regex, it's a giant Merkle tree. So you actually go down a chain and go up a chain, or go down a chain and go down further chain. So it's segmented. You can't really bounce that far from the rule you hit. Okay. Sorry, let me check my notes really quick. Bypasses all layer 7 scanning. We talked about deny options. Okay, actions, deny options. Here, if you talk about, it mentioned this in the study guide, so I want to touch on this. There are many different options when it comes to deny. I think the reason why they have it in the app ID area is because deny is actually application specific. The type of action that occurs will be application specific if you choose deny. That might be TCP reset. That might be TCP client. That might be TCP both, right? Reset both, right? But you can also override that and choose your own. So you could say drop, which is a silent drop. It actually says right there, silent drop, send optional ICMP. Reset client, which is it forges a packet and basically says the client reset it, but it sends it to the server. Reset server, same thing the other direction. And then reset both is it kind of forges response from either. So it resets from the client to the server and resets to from the server to the client, and it creates those reset packets for you. And then once a rule is allowed, it goes through your profile settings, which is all your layer 7 scanning. So once you have that fast path, you're going to go through your profile scanning, and that continually happens even on fast path. So I think that's it for app ID. Oh, workflow. Okay, I'm sorry guys for updating app IDs really quick. Let's say you have a new app ID database, because these app IDs are constantly changing, they're evolving, new ones are being added. Because new ones get added, your policy might change and your rules might change. And obviously that's kind of a problem, right? You want to be able to update these app IDs without breaking all your policies that exist. How do you do that effectively? Well, it comes down to the update. So go into your objects in your update. So either through objects or applications, you can see here, there's a button that says review policies here, and that will basically look at any disabled applications and apply them to your policy. Or what I think is more common and kind of being pushed now is through the device dynamic updates. So I'm going to jump over to device dynamic updates. This is where you get your app IDs updated. And you can see here there's a review policies button right on the application. So when you download it, you're going to click review policies or review apps, and it goes into review policies too. It's all kind of linked. Anyway, you can review the apps. Here's what's different about the content version. Obviously, we're on this content version on this box, so it's no different. And then you click review policies. And what that's going to do is look at the policies that are applying to that next update. Now, this can also be modified with this button here under your schedule. You can say disable new apps and content update. If you click this button, then you're going to have to enable them by going to the objects applications I was just at, clicking review. And then when you're happy with it, you can sort of undisable or re-enable those app IDs, and they'll start applying to your policies. I think these days, I think this is what's being pushed more is you download a new package, and then you review your apps for it. So
one question for you, Paul. I see they have the release notes there. Like, I was actually going to try to find a link, but I see they're on the firewall.
Yeah.
That would be a description of sort of what's new, what's changed.
Correct.
From the application side, right? Maybe there wasn't an app ID for a certain application. It always showed up as SSL, and now they created one or something like that.
Yep.
Right.
Absolutely correct. Yeah. And you can also see that under the review apps. So if you click review apps, it'll show you what's changed between the content version you're on and the content version you want to go to. And then you can review the policies, and that will show you which policies are affected by that change of app ID. So check that before you deploy it.
Right. And you can subscribe to that. I'll just maybe try to find a link in case anyone wants to do that. And then I think they just come via email when the new content package comes out.
Yeah, I'll drop this in the chat. This is the best practice guide for how to go about that. They do talk about subscribing to content update emails here under your support portal.
Thank you, Paul.
And then they also go through the do this and click these buttons to make sure that you're reviewing that stuff. So I'll drop that in the chat.
Right. Thank you.
Let's see if this actually has any difference here. Probably not, because most of the time app IDs don't get updated that often. Yeah, so this next patch would not affect anyone's policies, and I would feel comfortable clicking install without having to do much more. Awesome. That's, I think, all I got on app ID. Thanks for all the questions, Steph. That always helps. Mohammed or anyone, any other questions?
All good. Thanks very much.
Yeah. Thank you, Paul. It's a huge piece. Like, no one owns or manages a Palo Alto next generation firewall without dealing with app ID. You never, it's not an option. It's a core component. So thank you for touching on all those pieces. I think the next item Global Protect, and Mohammed, were you going to talk a little bit about that?
Yeah, sure. I can share my
Awesome.
screen. All right. So Global Protect. So what is Global Protect? It is Palo Alto's version of Remote Access VPN. It comes in two flavors, agent-based or thick client. This is where users install an agent on their machine or PC, laptop, and it creates an IPsec tunnel back to the gateway. The other version is the agentless, or people also call it clientless VPN. This is a browser-based VPN where users can, map applications to the browser, and users can access these applications just straight from the browser, of course, after authenticating successfully. At the very basic level, Global Protect have two major components. One is portals and the gateways. In the portal, basically the portal provides management functions for your Global Protect infrastructure. This includes configuration elements, list of the gateways available, and how clients are connecting to the Global Protect environment. Either it's always on, which is automatic, or user initiated. It's also called on demand. There are several tweaks you can make in the portal configuration, and those configuration are all passed down to the client's Global Protect client. Gateway is the other component. This is where once the tunnel is established between the client's Global Protect agent and the gateway, this is where all your policy enforcement comes from. So you will see the gateways could be the portal's firewall itself. So you can have a portal and a gateway on the same firewall, or you can distribute this to different multiple firewalls. When the client has created a tunnel to the gateway, this is where all the policies will come into effect, and all the good stuff that Paul talked about, the app IDs, and those will be enforced on the gateway itself. Let's quickly touch on authentication. Again, Global Protect is a massive topic. I'm going to keep my focus on what PCNSE Guides is asking for. I don't want to dig too much into the details. So the next topic they talk about is the authentication on the portals and the gateways. There are several different ways you can authenticate yourself. It's local authentication. This means you can have username and passwords stored directly on the firewall. So this is local authentication. External authentication, where you can leverage your LDAP server, your Active Directory, and any users in those AD domains will be allowed in. There are several other options as well, where you can have certificate-based authentication, and also you can add on multi-factor authentication using SAML, like Azure AD SAML multi-factor, or also through Radius, typically RSA token or something like that. And both the portals and gateways have that authentication section. So once you go into a portal, under authentication, you can define here which auth policy, authentication profile that you want to use. This could be a Radius, local auth, and so forth. And similarly, same thing in the gateways. You will have an authentication section here. Just to keep in mind, since the portal and gateway have separate roles, you can authenticate differently on each of these components. Let's talk about a little bit of Global Protect licensing. by default, you can deploy Global Protect portals and gateways without license. So majority of those functions will work. Where you will need the license is when you want to deploy clientless VPN, Global Protect mobile deployment like Android or Apple devices, IPv6, and also HIP checks. HIP checks are basically compliancy checks that is done against the client machine. When a client connects to Global Protect Gateway, uh, the HIP checks are done on client's antivirus software, whether it's installed, whether it's up to date or not, Windows patches, for example, and all this information is collected from the client machine through the Global Protect agent and sent over to the gateway. The gateway then receives this information and checks against all the policies that are defined by the administrator, and then lets in the client or denies the client's connection. The last section that the PCNSE guide talks about is split tunneling. What is split tunneling is basically the traffic that needs to be allowed through the tunnel. For example, a lot of customers have decided we don't want to, traverse all the SaaS application, for example, Office 365 through the tunnel. So what happens is you can go ahead in the gateway. I'll just show you where it's configured as well. Client settings, under client configuration, split tunneling. So you can define what's included in the tunnel and what's excluded. So you can use domains here. You can use IP addresses or IP address ranges. All those good stuff can be configured from a split tunneling. This is a great way of defining how much traffic is traversing through the tunnel versus not, depending on your deployment. If you have a smaller firewall at the hub site, then all your SaaS application should be, excluded from the tunnel transport, and also any of your video traffic, for example, any VoIP and video traffic, you don't need to backhaul back to your data center. You can just always traverse that outside of the tunnel. So that is split tunneling. So these are the major components that the PCNSE guide talks about. I'll stop here. If there are any question, shoot out and we can dig a little bit deeper into those.
I'll throw, well, maybe it is a question, I think, eventually, Mohammed.
Right.
But I know the portaling gateway to me was new with Palo Alto. So that construct, and I'm trying to think back, I don't think I had run into that, if it was a Juniper SRX device or a Cisco ASA device or another appliance that did essentially like remote VPN or client VPN. But it might be wrong. You guys might have run into that, but I recall being sort of a little bit confused at the portal and the gateway construct. And I think, and welcome feedback, and it's sort of an open question, I guess, because I don't know if you guys know, but it seems like it was designed at scale to support multiple devices, because when you're doing everything on one box, it feels a bit redundant. I have to go configure the portal, then I go configure the gateway. But I think in a larger deployment, it allows for the portal being authentication and optionally to get configuration on what gateway to connect to. So I just wanted to throw that out and ask you, Mohammed, like, was that unique from your understanding too? I know you've done a lot of work on Cisco devices and others, and maybe qualifying the portal gateway difference if I missed anything there.
No, I think you're absolutely right. In other vendors deployment, as far as I know, this configuration is combined. So the portal and the gateway combination is defined on a single device.
Right.
But what Palo Alto has done, as you have mentioned, it has taken a step further where they have differentiated between these two components. Portal provides you that authentication mechanism, and after everything is done, then the client can connect to the closest gateway that is available to them. So in a fashion like this is a large scale deployment, right? So you could have, as I was saying, the portal and the gateway could be on a single firewall if it's a small environment, or in a
Right.
large environment, the gateway functionality is removed from the portal or the hub side and assigned to each of the branch offices. So wherever
Right.
the client is closer, it will connect to the gateway and have that tunnel established to the closest gateway. Yeah.
Awesome. Thanks, Mohammed.
Yeah, no problem.
Excellent. I think the next subtask is decryption. I think you were gonna jump into that one, Jawad, if I'm not mistaken.
No, you're not.
Good.
Hey, everyone. Okay, share my screen. So we did touch on decryption. I think that was on webinar 2, more from high level. So I'll do a quick refresh on that, and then we can jump on the demo firewall and go more into the details of the configuration and setup of decryption. Sorry. Yeah. So from high level, again, why we need decryption, SSL traffic on the rise. Most of the internet traffic today, I would say close to 80–90% is going to be SSL encrypted traffic. So when traffic is encrypted, there's much less visibility by the firewall in terms of what Paul was talking about, identifying those applications in a granular fashion. And then also lack of basically ability to do a lot of the threat prevention capabilities. So decryption is not an end goal by itself, but it's more to enable us to take advantage of all the other features that the firewall provides. And for decryption, we don't need, again, additional licenses. It's very flexible. It's policy-based, so you can have that control on what you want to decrypt and or how to go about it. 3 types of decryption that the firewall does: SSL forward proxy, that's mostly outbound decryption; SSL inbound, that's inbound from outside to your servers; and then SSH proxy. We talked also how that happens. So from high level forward proxy, this is internal users connecting to external servers like the internet. The firewall acts as a proxy, sits in between, it intercepts the traffic, and then reinitiates the SSL connection to the server. And the server sends back its cert. The firewall checks the cert and then decrypts the traffic and does all that scanning and application identification, and then reassigns the cert with its own CA cert back to the end client. Similar to this is SSH proxy. Again, the firewall is intercepting SSH sessions. This time it's not using certs though. It's just the SSH key, so intercepts that session between the end user and the server, and this could be internal or external. And again, the idea is basically to have that visibility on SSH and to scan if there's tunneling happening or bad things happening, then it can basically have better control over those SSH sessions. Then inbound decryption is mostly the use case would be published internal services to external users. This one is different. The firewall is not acting as proxy. It's not sitting like in the man in the middle. It's basically you just load the cert of that server, and the firewall is able, basically, because it has that cert, to in parallel basically decrypt the traffic on the fly and scan for against threats and things like that. Okay. So the one that requires most consideration and planning and is the most commonly deployed would be the outbound SSL forward proxy, because ideally you want to decrypt internet or external user to internet traffic. And that requires certain components that we need or prerequisites to have in place before we're able to apply that decryption. One of them, very important, is certificates. So as I mentioned, the firewall, because it's intercepting that traffic and decrypting it, it's gonna use its CA cert. And that CA cert could be a locally generated on the firewall, but that's not ideal for production or wide deployments. more ideal is to issue that cert from the enterprise CA. And how this happens is you can generate the request from the firewall, send it to your enterprise CA, get it, issued, approved as a CA, and then sent back loaded on the firewall. This way, the private key doesn't leave the firewall, and this is gonna be a CA. You have the private key, and then basically you're gonna check the forward trust certificate box here. So that's one cert. The other cert that also is required is the forward untrust cert. That one usually the recommendation is to be locally generated on the firewall, and this is for sites that are untrusted, that are visited by the user. Then they would get signed by that untrusted certificate. So this is the certificate requirement for the SSL forward proxy. In case of inbound certification or inbound decryption, then all you need to do is load the server certificate on the firewall, basically. Moving on, the other thing to talk about is SSL exclusions. So we know with decryption, there's certain sites or domains or URLs that won't decrypt. And luckily, fortunately, Palo Alto publishes a list of known domains and hosts that don't decrypt, basically don't work with decryption. So that's under the certificate management. There's an SSL decryption exclusion. So these are all the ones or predefined exclusions published by Palo Alto. They also, under description, they would list the reason of why that won't work with decryption, like pin cert doesn't work with decryption, two-way authentication, client cert auth, all of that. So all these domains are basically going to be excluded from decryption. You can also add your own domains or hosts as well under this list. The other way to exclude domains or URLs from decryption is going to be under URL categories. You can create your own SSL no decrypt custom URL and then include all the URLs and domains you want to exclude from decryption. This is a very common way of basically including or whitelisting sites and domains from decryption. The other component to talk about, I'm not going to go into it because it's going to be covered in the next section, is the user ID. So user ID is usually a prerequisite as well for the SSL forward decryption. Having the user ID configuration set up in place as well as user groups, very important and basically to be included in decryption policies. One last component to talk about is going to be the decryption profile. So under Objects tab, there's a decryption profile here. And the decryption profile basically, which is configured from this section, is to provide the ability to add additional controls and checks on decrypted traffic. So we've got the three types: SSL forward proxy settings, SSL inbound inspection settings, and SSH proxy. So you can, for example, choose to block like expired certs or untrusted sites and or unsupported versions, cipher suites, things like that. So you can do those settings for each type of decryption. And then you can even do expired certs, untrusted issuers. You can block those even for non-decrypted traffic. And the last thing here is the SSL protocol settings. If you want to basically just secure that you're allowing like secure TLS versions, you can set the minimum version here. And when you set the minimum version, you can see that some of the older unsecure protocols will be disabled, like you can't check them anymore. So it's enforcing basically the higher, more secure encryption, authentication, and key exchange algorithms. Again, for decryption profile, it could be one profile where you configure all these settings for all the different types of decryption, or you can choose to have separate profiles for each one. Once we have all these components configuration built in place, we're ready to deploy or apply decryption. And this is gonna be under the policies. So under policies, under the policies tab, you have decryption here. And this is where basically you're gonna be creating your decryption policies. So I'll start with the SSL forward proxy decryption policies. Common deployment we see is on the top of the rule base here is gonna be a no decrypt policy. So this is where you have that SSL no decrypt custom URL I showed you, which have your whitelist URLs and domains that you are excluding from decryption. In addition, there are some predefined categories that Palo Alto and generally recommended not to include in decryption, like financial services. That's all like the bank sites and financial sites. Government is another one, health and medicine. So all the categories you want to basically exclude will be in this policy here. And then the action for this one will be no decrypt. So if you look at the tab under the options, this is where you apply the action. And for this one, it's going to be basically action is going to be no decrypt for SSL forward proxy. You can still include as a decryption profile, even for non-decrypted traffic. So you can add that in here.
And Jawad, if you
Yep.
add the no decryption on the no decrypt, when you add a profile to it, are you just checking against some bad certs or expired certs, something like that?
Yeah, just basically expired certs, sites with expired certs and untrusted issued certs. Exactly.
Perfect.
Yeah, that's gonna be it. And then usually, again, this is phased approach with SSL forward decryption is best to be tested initially, and you can control that. Again, this is a match policy. You can control that by having a test group, for example, user group here, and then start decrypting with specific, let's say, non-business categories like social networking category, search engines, and other ones. So run that, with test users so you can identify any gaps or issues with your decryption deployment. Maybe you need to whitelist some sites reported by those users, or maybe you need to include some certs basically to trust some of those sites. So have that basically the issues short up, and then you can move into deploying this more into like internet users and on all categories. That's SSL forward decryption. Then moving on, SSH proxy is simple. Basically, all you need is to have one policy or maybe two policies, inbound, outbound. And then you can specify that to port 22, or you can even keep it more open. And the action here or the type of decryption is going to be SSH proxy. Under the option decrypt SSH proxy, and you can include a SSH proxy profile as well. And then inbound decryption, again, it's usually the outbound or external zone into your DMZ zone. And here you have to match on your specific servers you want to apply inbound decryption to. You can specify also the ports. Usually those are the open ports on that server, like 443 and 80. And then you're applying SSL inbound decryption action in this case. So yeah, this is basically covers the decryption configuration. Now, in terms of troubleshooting decryption, once you have decryption on, to confirm that traffic is being decrypted, the first thing you can check is on traffic logs. There is a column called decrypted. If it's not showing up, you can add it basically by checking that column in here. And this is gonna tell you if the traffic is being decrypted or not. So I'm gonna just remove the not here. And yeah, if the traffic is being decrypted, you're gonna see yes here. And then you're gonna notice that you're gonna start seeing more applications. So this is gonna impact the policy once you turn on decryption. So consideration about your policy, updating the policy applications. That's one aspect also of turning decryption on. One common thing we see with decryption, you're going to see with decryption is web browsing on port 443, because initially this is coming on 443, was identified as SSL. Once you turn on decryption, now it identified as web traffic, as web browsing. For additional or deeper troubleshooting in PanOS 10 version, they added decryption logs, very useful for troubleshooting decryption issues. So under decryption logs, you can see the policy, the decryption policy that's being hit, the type of decryption, forward or SSH or inbound. And then you can see all the details about the certs. And most important is to look at the error and the error index columns, and they're gonna provide basically an idea or a reason for if there's an error with the decryption, like if it's TLS error or a cert, untrusted cert, or some other type of error. Is gonna show those details under those two columns here. And that's very, very useful for troubleshooting those decryption errors. And then basically dealing like from experience with those issues, it's gonna be either whitelisting that site from decryption, either through the custom URL or the SSL exclusion list. Or it could be, for example, the firewall is not trusting that site, then maybe importing the cert and the device here in the cert, and then labeling it as a trusted cert, and then the firewall will stop blocking that session. I think that's all I had. Any questions from anyone?
The one question I had, Jawad, was when you are deploying decryption, this can only be done on service ports, but not app ID, correct?
Yes, decryption. Yeah, that's gonna be basically matches on service ports, not on application.
Okay, this could be
You're
a trick
right.
question
Yeah.
from a PCNSE exam, like on what categories you can do decryption. It would be even URL categories or service-based ports. That's all. Okay, thanks.
Yes, the matching, absolutely. It's gonna be most common on the URL categories and the ports.
I had one question that Paul answered by putting a cool link in the chat. And I was gonna, and maybe I'm actually curious. It's fun to follow on question about the secure ports, but maybe I was gonna try to connect it back, Jawad, to Paul's app ID piece. So maybe just bear with me. You guys can correct me if I'm wrong, and then I'll shape up the last question, which was new because you answered the first one I had, Paul. So Paul, you went through that the firewall first looks at essentially ports, TCP or UDP ports, to initially allow the traffic. And then app ID inspection determines hopefully an application, and it could shift. And you just went through decryption, Jawad. So that if I'm gluing these things together just in my mind, the it would be a service port allowed, determined it's going to be SSL traffic.
SSL.
And then when it's SSL traffic, it's testing that decryption policy that you have on your screen right now, Jawad. And if it's a match condition, it will decrypt the traffic. And if that all works successfully, App ID is going to continue to discover new applications now within that stream, and it's going to go back and hit the policy again and match things, other applications potentially. I know the web browsing on 443, I remember from a long time ago. And then the link Paul just put in was really that it seems like after PCNSE 9, they sort of did that for you because there's a new secure port saying web browsing is actually only on 80, but in that case you brought up, Jawad, it actually will show up on 443 because it's decrypted and it's web browsing traffic, which will shift to another web app. Do you guys know if that secure port definition, is that in all app IDs now?
Not
or is
all.
that an exception to just web browsing?
If I could jump in, you know that part, Steph, where you said once it starts discovering new applications and it's being decrypted, it goes back to the policy base. When it has the flag decrypted, it goes back to the policy base with the secure ports as application default.
Oh.
So
and
LDAP, but on S is going to be 636 or whatever. It's going to be looking for LDAP on 636 rather than LDAP on I can't remember the standard port 389.
Right. So
389.
So that's 389.
Mohammed's got them all memorized. I love it. The what ports Telnet, Mohammed? Just joking. The secure ports are across many app IDs then, because another thing that you put in the chat that was awesome, Paul, was the Applepedia, which I hadn't been to a very long time, but they don't have secure ports on there, which I sort of think is funny. They should.
Yeah, I noticed that too. They should. I don't know if
okay.
It's just not a field that they're adding to, I guess. But you can see them in your firewall. You just have to go to the firewall, and at the very bottom of the latest link there, web browsing, LDAP, SMTP, POP3, IMAP, and FTP. Again, SSL with FTP inside, SSL with SMTP inside. Web browsing, LDAP with SSL.
Well, that's huge. Yeah. So when it's using different standard ports, if the decrypt flag is yes, like it's gone through that part of the loop. That's cool.
It's bringing that context of it's being decrypted back to the policy base. When it does the app ID lookup, it knows that the application default port it should be looking for is not the standard one. It's the secure port listing instead. But if you're using non-standard secure ports, then you do still have to create those policies.
Yes. So it helps for the case that Jawad mentioned and many others where it's like this is an encrypted port, but it's actually showing up as unencrypted because the firewall's decrypting it. So there's after PCNSE 9, like it's a lot more friendly.
Yeah, and I think it's even more.
But you still have to be aware of it.
You set application default, and if it's non-decrypted, then it will be the first set of ports, and if it's decrypted, it'll be the second set of ports. So it's actually more specific than if you create a policy that said allow 636 all the time, not if you're in the context of being decrypted or not.
Okay, awesome. No, thank you, Jawad, and thank you, Paul. I'm just going to do a quick announcement as a time check because we have reached the hour. But like we've done before, I think we can keep going and get through all the content. But I know some people may have to drop. Don't worry, we're going to record the whole thing and we're going to stretch to get to the end of this exam domain. So I think the next is user ID. I think you were going to take that one, Paul, right?
Yeah, absolutely. Right. Happy to. Thank you very much, guys. Okay, user ID. So I'm going to do a quick high level of user ID, and then in user ID section, they primarily focus on the dynamic updatable groups. So we're spending a lot of time on that, basically. So in the concepts, we talked about user ID. What is it? It's basically identification of users so that an IP gets mapped to a user. And that IP then can be used in a policy, essentially, by way of a username. But it really comes back to an IP, right? It's just the IP at the time that's been flagged for that user. So how do you get these IP to user mappings? Well, it comes in many different forms. We talked about them previously, but I'm going to just list this basically: server monitoring, port mapping, syslog, XFF update, headers, username, header insertions, authentication policy, global protect, XML API, client probing. Those will probably be on the test. They always seem to have a question where it's like, what are ways you can get user ID, and it will have like 4 on A, B, and C, and D, and you have to make sure you know those. So straight up, just memorize them or look at them before you go into the test. I don't know, whatever floats your boat. So yes, user ID methods, those are them. Basically, these are ways to get username to IP address mappings. The most common ones are things like server monitoring, which essentially is syslog, Active Directory, like file monitoring. Successful authentications to your Active Directory can create a log file, and if you're monitoring that server's log file, then you can identify the IP to the user mapping. So what's this look like? Basically under device, data redistribution. This is different now. It used to be called, well, there's two sections now, user ID and data redistribution. They've moved some stuff around. So for anyone who's done this in the past, it's good to refresh yourself on this. User identification no longer has where your agents are. This used to have where your agents are located. That's no longer the case. So user identification is where you do all your settings and configuration for user mappings, terminal server agents, which is still there. Group mapping settings, which is basically how you map your users to groups through like an LDAP query lookup that the firewall can do for you, or you could do an LDAP proxy through one of your agents. And authentication portal too, which we're not going to get into, but if you want to set up a captive portal, that's where you would do it too. Data redistribution is where you have your connections to your agents. Now, agents is a little bit more wider these days. Agents could be another firewall that has user ID information. It could be a panorama device that has user ID information, or it could be an agent, a piece of software you load on an Active Directory, for example, or a terminal server, and that is constantly looking and monitoring and getting those IP mappings, and then you connect to it on like 5007 by default, and you create a TCP connection, and then you pull that information back dynamically. So that's data redistribution and user identification are the two sections you really need to look at. So the one piece they focus a lot of time on, so they don't focus a lot of time on in the study guide on, I'm going to go through this really quick because we're going to get to dynamics. So agent is, again, the one I just talked about, the software loaded on the Active Directory. It is a piece of software, and there's a few different agents. There's one that does split boxes. So if you have port mappings, think terminal servers, there's a terminal server user ID agent. There's also different versions of user ID agent for if you want to do Bloom filters, password protection policy. So in your URL filtering, when you're doing the second column, that's basically post.
Is that credential theft, Paul?
Credential, thank you. Yes, there's user ID agent specifically for credential piece as well. So if you do want to do the credential stuff, you have to put a slightly different user ID agent on. So there's user ID agent, terminal server agent, and then the credential plugin or agent version. You can also do agentless. Agentless is basically you give credentials to your firewall, and your firewall does the queries directly, kind of like DCOM to the Active Directory server or the domain server itself. User ID mappings is just essentially that, just getting the mappings back. Not going to go too hard in detail. It's pretty specific here on what it's doing with your logs and your requirements and your security policies. And then shared user ID maps across virtual systems. So virtual systems, VSYSs, do not share user ID information by default. You have to basically go and create that configuration. You go into the VSYS tab, you check a box. I think we talked about it in concepts already. Once you check that box, it does share that information across VSYSs. Data redistribution is the concept where you can basically make other firewalls or panorama devices agents, and you can pull them and push to them. So when the agent is in your listing, you're pulling from it. So if you want to do a push and a pull, you kind of need to do it both ways. This one needs to be an agent for this guy. This needs to be an agent for him. And you guys can share that way. There's a good graph, actually. Think about pulling it up, but you kind of share up and then pull down. So that you're not duplicating or looping kind of information as best you can restrict. So there is some concern there. Does a pretty good job. I've been in environments where they do share between areas, consider like an A environment and a B environment, and there's like a cluster in each, and they share between each other. It worked well for us. And there was no issues with like looping information or CPU consumption or anything like that. So it's pretty flexible as far as that's concerned. But typically distribution kind of goes up. Like a panorama or something, it goes up into like your more larger devices, and then you pull down into your smaller devices from there, right? So collect up, pull down if you need them. And then yeah, the methods, you just want to sort of know those. The XML API, we're going to touch on dynamic groups, is effectively the API, right? So it's not the REST-based API. There's actually two APIs. There's an XML API and a REST API on the Palo Alto. REST API is newer. The XML API has been there for quite a while, and most of the front end interacts with the XML API. So that's you being able to connect, authenticate to a device, and then push user ID mappings. You also can push things like tags, and that's when we're going to get to user dynamic groups. So user dynamic groups is exactly what it sounds like. It's a group where the users are dynamically added to based on a set of tags. And so you basically take a user ID and you can tag that user ID. And with that tag, you can add them to different groups so that the policy can effectively change dynamically based on if a user is part of a group or not. So if you have something like infected users or infected workstations or infected users, let's say, because it is user ID after all, you can tag someone as infected, and then they can dynamically show up under the infected group. And when you do that, you can apply different policies. Let's say you block them from accessing critical areas, or you only allow them to access something like your antivirus or endpoint protection systems, things like that. So they do focus on dynamic groups quite a bit here, and they talk about the ability to tag and untag through the API and through user ID agents. Specifically, we'll just say tag username by using the XML API, right? So they're really talking about how they integrate this with other products they have, right? Palo has lots of tools for things like this, but you can do it through your own systems. They talk about doing it through a SIEM here. So leveraging users' entire known security state. So either firewall logs or SIEM or UEBA. You're going to want to use all the information you have to sort of tag that username with the information that you need, and that will change the way that their policy affects them because it will change the dynamic group they're part of. So there is typical groups, Active Directory groups, right? You can bring those into your policy base. You can say help desk, frontline workers, or let's say finance is allowed to do certain things. You can bring those groups in, but you can also create dynamic groups that are only within the Palo, and a user can exist as one or more of those, and policies will affect them top down, like we talked about before. That's really, I think, all I wanted to touch on. Let me show you the areas in user ID, and that's about it. So user identification, this is where you're going to set up your load for me, but you're going to set up your how you do those user mappings. One thing here, just to note, I think I might have touched this all in concepts already, but enable probing is questionable these days. Probing is the ability to send a request directly to the system that's unknown. And if you do that, it will log into that system and try to identify who's on that system at the time. If you're doing that to an attacker's machine or a machine you don't know, you are effectively authenticating to that machine. So if someone's running something like Responder or just listening, they might be able to be stealing hashes from you. So make sure you're only doing it to systems or areas that you know your users are in and not to other systems. And to that point, you do have to add user identification to a zone. Constantly gets missed. It's kind of a strange thing, but you have to apply user ID into a zone. So when you're in the zones tab here, you can see the user ID here even before it loads. The enabled flag here is a checkbox. And for every zone you want to do a user ID in, you have to flag that. Include and exclude networks can be done on a zone, or it can be done on the device bases here. And either way, basically what you're doing is you're including or excluding areas. There is kind of a logic to this. If you add an include statement, everything else is kind of excluded. If you add an exclude statement, everything else is included. And this is better described in some documentation. I'll leave it for them to specify it correctly. Basically the idea is you want to include areas. You don't want to include all subnets, for example, most of the time. Back to Jawad's decrypt, actually. If you're decrypting based on user identification, remember that user identification is down to a successful login to a computer's IP. So if you have an administrator who logs in remotely, or you have a common box that's being logged into by multiple people, you can only identify that IP to one user at a time. The last one who logs in is the one who owns it. So if you have a decrypt, for example, rule, and there's an admin who's, let's say, being tested on decrypt, and he goes and remotely logs into a system, that system just got added to your decrypt policy because that system just got logged in successfully by an administrator who might have been testing some decrypt policies, and that computer system is now being identified by that user ID and could be decrypted outbound. So just know how that works, and that's one of the reasons why include, exclude networks are important. You can include, exclude areas, maybe like your jump host you come from, so that you don't identify users when they come from that area or when they log into that area. So there you go. Cloud Any Engine is something I just want to touch on really briefly. It's a service that's in the cloud that Palo's been pushing a little bit more recently. It sounds like they're going to even be doing more features in that area, but it does group mappings, and with cloud to cloud connection, you can basically have it with APIs connect to your Azure tenant, for example. Most people are kind of like hybrid Azure at this point, and you can just log into that Azure AD from the cloud to the cloud. It's very quick that way, and they can pull and map all of those groups and users back, and then you can pull from there. It does not have at this time the IP to user mapping though. It only has really the group mappings. What users are part of what groups. You could get that through LDAP, for example, or you could get that from the Cloud Engine. I think these days I would probably be deploying Cloud Entity Engine for that level of mapping because it's universal, it's very accurate, it's cloud to cloud, it's quick that way, and it's always there, rather than having to like an LDAP query that you might block or have other problems with. Yeah, but remember that the that the IP to user mappings is not there at this time. Who knows what that's going to change in the future. Questions? That's all I really want to go over.
That's awesome, Paul. Thank you. I always thought the dynamic user group feature was sort of pretty cool, but often underutilized and under showcased principally. But yes, I'm glad it's on the exam.
It's a major part of it. According to the study guides, about 50% of what they want us to know about. So it's all about like going into this, and I guess I can just show everyone this. It's objects, dynamic user groups, add, and then it's basically a filter of tags.
Right. And then a
apparently
tag
demo box is having an issue.
And then a register on register function based on those tags fundamentally. Yeah.
Essentially, yeah. And you can register and unregister those tags to users, and those users will become part of the groups.
Right. That is neat. Awesome. I think the next and second last, but I think these items aren't quite as big as far as the other topics we've been going through. The next one's wildfire. Were you going to jump in on that one, Nathaniel, and talk a little bit about wildfire?
Awesome. Yeah, I can jump in on that.
Perfect.
Okay, I'll just share my screen here quickly.
Yeah, sounds good.
Okay, I'm going to use our firewall because I don't have access to the demo one at the moment, but doesn't make a huge difference. Anyway, okay, so Wildfire is a tool on the firewalls that it does require a license, and pretty much what it does is it takes it uploads previously unknown files, and it will identify them as being potentially malware or other. It can identify stuff like phishing emails and links to that as well. And it does that through either a public or private cloud. And I think the easiest way to just go over all of the things that it can do is just by sort of going through the firewall here and going to the configuration sections. So first section for Wildfire on the firewall is under the device tab, under setup and Wildfire. These are your general settings. So if you go into here, if you have a Wildfire appliance, which is something you can purchase, you can do private cloud analysis, but in this case, the public cloud is what most people will do. This is the link here, and pretty much when a unknown file signature is identified, and based on the type of file, you can see them listed here. There's more details in the guide. We'll look at that in a second. Pretty much, if a file is under a certain size and it meets any of these requirements, it will be uploaded to the cloud, and then it can be identified as either benign, grayware, phishing, or malware. And then based on that, Palo Alto will add the signature to their database, and these signatures are published almost nearly right away for people that have the Wildfire license, and then after a day for people that don't. So you can see here the file sizes. These are pretty good by default. They sort of cover all of the general max sizes for a malicious file. Anything bigger than this tends to be legitimate. Of course, there are exceptions, but you don't want to be uploading huge files to Wildfire all the time. It'll obviously cause network performance degradation and all that. So these are sort of the defaults. There is the options down here to report grayware files and benign files. Benign files you usually don't want want or need to report them because of course they are benign. So that's usually left unchecked. Grayware is optional. Grayware usually includes stuff like spyware, as well as adware, stuff that it can be malicious, so you might want to check it, but it's usually tends to be something that won't negatively affect you to a certain degree. It's the lower end of the bad files. Of course, phishing and actual malware will they're forced to be uploaded when you have this enabled, so you don't have to worry about those. On the bottom here, you can select the session information settings you want to send. So this is pretty much if you're concerned about privacy on your network. If you don't want the public cloud to be getting information that you care about, such as users, email sender, recipients, as well as all these other options here, just for security reasons, obviously. It's very secure, so most people leave all these selected, but you do have that option if you want. So once you have this enabled, you can go to the objects and wildfire analysis security profile. There is a default profile set in here. This is where you configure what you want wildfire analyzing. So you have the option to choose any application types that you want. If you uncheck any here, you can see there's pretty much anything that app ID covers. You can really refine it if you want to, although in this case, leaving it as any covers the widest range and obviously will protect the most. So that's how it's usually left. In regards to file types, this is where you can select those file types that we talked about earlier. If you only are allowing certain file types through a zone, for example, then you don't want to have everything selected. So it just gives you that little bit of extra filtering. And then obviously there's upload and download direction for the files and choosing how you want to analyze it. So
Awesome.
yeah, let's just go back quickly. Yeah, so this just defines what each verdict covers. We already talked about that. Yeah, phishing tends to be the most common one that I'd see. You get like if anyone in your network gets a bad email with a phishing link, it can usually identify that. There are, of course, false positives, but that can be remedied. And then malicious is the one that really care about. So yeah, this is what each file type covers. All those file sizes. And then one more thing I want to talk about is the schedule for the wildfire signatures. It's at the bottom here. You can see that this device is set to download them every 15 minutes. They do tend to come out fairly often. And this just pretty much is once those signatures are identified by the public cloud, Palo Alto will publish them to everyone so that they can be prevented on every device. And again, this is once every day for non-licensed firewalls, and then immediately for everyone that has the license. Is there anything that I missed there? Anyone? If anyone wants to add anything to that?
You did a good job, Nathaniel. I know,
Okay.
and kudos to you for jumping along with us. I know this is all fire hose for you because you've not spent years on the Palo Alto platform. So yeah, thank you for jumping in. I did have one question to help me because it might have changed, and it may be more of a team question because I'm not too sure if you know, Nathaniel, but all of that profile setup, and I know that elements in the study guide, the actions of like the firewall doing something when it's not benign, historically, I think that was through the antivirus profile. I don't know if that's still the way it is. I guess just thinking outside one step beyond the content here. This is about how to set up the wildfire analysis and the profile. What do you want to send for analysis? And then you went through the, after analysis, it can be one of those 4 things. When it's one of those 4 things that are bad, how does the firewall block it? Do you guys know if that's still the case? Is it still blocked through the antivirus profile, or does that happen differently now?
Believe it's part of the antivirus
Yeah,
profile.
mostly
Okay.
antivirus, but there's also inline machine learning addition in the 10 version, and that's included
Okay.
in both the antivirus and the URL profile. So things like phishing, unknown, phishing sites and
Okay.
things like that, that's part of the URL profile, inline
Right.
wildfire.
So there's, and I guess that makes sense, Joad. Like when something is run in the wildfire cloud and it's bad, there's many attributes they know about that bad thing, including URLs and maybe the file that it spawned from. So that makes sense. It might be more security profiles that sort of that the known bad is getting pushed back to.
Yeah.
Awesome. Okay. Last but not least, thank you, Nathaniel, is the web proxy. Now I'm happy to open this one up if you guys want, because I was like, what the heck is web proxy? And if you guys are up for it, I want to share just one quick, actually, yeah, you're sharing. I'm going to bring up one quick screen.
Okay.
And then I'm going to let you guys rationalize how it was, because I was completely caught off guard. And I'm like, what is this? This is something new, obviously. What the heck is it? So 2 pages, and I can put these links in the chat. So you guys can see the screen, and I'll put these in after. It's a feature. It seems like it's a new feature. So PCNSE 11. It seems like the intent is migrating from an existing web proxy architecture. And it also is involved with Prisma Access, which is for an oversimplified term, the firewall as a service. And it's also on limited hardware models. So that was really interesting to me. I was looking this as a use case of someone that maybe had a secure web gateway, and they're using pack files and proxying to get the traffic there. And there seems to be a way to leverage that same architecture with some Palo Alto firewalls now. And the second page that I'll share out really talks about how Prisma Access supports proxy traffic. And so I read this as maybe this example is obviously coming from a mobile user with a pack file installed, but there could be a helper spot here with one of those newer PA series firewalls that has this new feature to help bridge the proxy use case into Prisma Access. So I thought that was really interesting. Don't fully understand it. I'm going to stop sharing that, and I put the links in, but maybe pass it back to the rest of you guys that may have dug deeper on that last topic of configuring web proxy.
I've got nothing to add to web proxy. It's
I
really
don't,
new.
yeah.
It's limited. I've never deployed it. So read the documentation. Good luck on the test, everyone.
It's nice and tied up, I guess. It is what it is. Yeah, no one's used it. Did you guys get any sense for other use cases or anything other than the ones I just quickly shared on the screen? No. Okay.
Maybe an alternative to SSL decrypt. Like I'm curious how that operates. If it's SSL still to them and then it's SSL after them. I don't know.
Yeah.
I don't know if you need a license for Prisma Cloud either. But I don't.
Yes. No, it's all good. So that's good advice. Look at the content in that study guide so you can pass the exam.
I don't have a lot there.
No, and that's like, I think that's what we'll have to do as we renew. I think you and I are in the hook for renewing Mohammed sooner than later, right? So awesome. Excellent.
I have one thing. I do have
Yeah,
one thing, sorry, if I could. I didn't do justice to something that is actually really focused on in the user ID section around dynamic update groups. I'd love to just touch on. I don't think we've deployed it a lot, guys, so this might be a little new for all of us, but it's the built-in actions under log forwarding. If you guys haven't used them, I don't see it deployed a ton, but this goes back to user ID dynamic groups. So I talked about how the XML API can tag users, and then they'll be added to a group, but you can also do this on the box through this. I don't think I did good justice on it. So just really quick, when log40 profiles, which again are added to your security policies, hit a log, you could filter this, for example, to say like threats as a common example, right? You can have a built-in action. So let's say if there's a threat of hi, you could actually create an action within the box based on that. And this is something that I haven't used a lot. That could include the user, for example, and you could register a tag on them. So let's say we wanted to register a tag of bad thing happened. Within this, a threat of hi could create a tag dynamically in the box, and that means that they would get added to that group, which means then you have different security policies applied to them. So just want to touch on that this is something where you can have some of that automation occur right in the box based on traffic it's seen. Let's say there's a wildfire log, or there's a bad file, or there's a vulnerability or something that the user did something strange, or even if they just accessed a policy, they accessed a certain traffic policy like URL filtering category or phishing or something, you could actually dynamically create those tags within the box and add them to that group, which then could have changed the policy that applies to them. So just wanted to touch on that really quick. Sorry I didn't earlier. Okay.
No, that's actually quite interesting, Paul. So you can use the logging traffic as a source to create a match condition to then apply a tag on an object and have it sort of be in a different part of the policy, like isolate a host or put them in a more restrictive policy or something of that nature. Yeah, very cool. And I'm assuming there's time limits on that for how long until tags expire and those types of parameters. Yeah, that makes sense. Another underutilized feature. That's very interesting.
Yeah, and in practice, I haven't seen it deployed a lot, but maybe it's just because it's new and it's not out there, or maybe I'm just and quarantine is something else. That's an IoT quarantine device thing, but this one is what I'm talking about, and it's source address could be address group tagged. User could be tagged, which is closer to the dynamic thing, and like you said, Steph, there's a time limit here, and there's a max.
Okay.
So
yeah, very cool. Thanks for adding that in, Paul.
Yeah, sorry I didn't get it before.
No,
awesome.
That is awesome. Well, unless there's any other comments or questions, we can wrap this one up. Thank you guys very much for joining us, and thank you to you guys, to our team that took the time to go through these domains. Until the next one, thank you guys. Take care.